This video shows two more examples of trig integrals, in particular two that start out looking very similar but take very different paths. So in this first integral sine x cosine x over 1 plus sine squared x. And there's no identity that simplifies 1 plus sine x squared, so we have to just deal with that denominator as is. So we'll try picking that denominator as u. And if that's u, du equals 2 sine x cosine x. Well, that's useful because that is almost identical to the numerator. We just have to multiply by 2, put a 1/2 outside the integral, and what we get is 1/2 integral du over u, which of course is 1/2 log the absolute value of u plus c, equals 1/2 log, and we don't need the absolute values because this u, 1 plus sine squared x, is always positive. So log of 1 plus sine squared x quantity plus c. And that is the antiderivative. Now the second one is quite similar. It just is lacking the factor of sine in the numerator, but otherwise it's identical. But unfortunately here, we can no longer use the denominator as u because we don't have the proper du. Instead, notice what happens if we use u equals just simple sine x. Well, then du, of course, just equals cosine x dx. And what we get here is du over 1 plus u squared. Now, this is a very different integral pattern, but this is an integral pattern you should recognize at this point. This is the arctangent, or the inverse tangent of u. And so this integrates to arctangent of sine x plus c. So a very different outcome from a similar integral.